Inverse of trigonometric functions. Here's the unit circle. If you haven't got it memorized by now, please continue to keep working at it. As you notice, it has its exact values at a specific point. It has the radians and the degrees on here. It has the quadrants and the signs in each quadrant. It has the order pair and tangent here. So this is very helpful. And then you have some helpful information on labeling that might help you. So definitely keep working at memorizing it. It will help you in this course. This next table is showing you what the inverse functions are for sine, cosine, and tangent, and where they fall at on the unit circle, which makes sense since sine is the y value on the unit circle. It does fall from negative pi halves to pi halves. And then cosine falls from 0 to pi. And then tangent, since it's sine over cosine, it's going to fall on the y values as well. And I just want to do a quick reminder. So when you're in college algebra, you're given a function and you were told to find its inverse. So what you would need to do here first is put y in the place of f of x. And now we're going to start finding its inverse. That means we're going to switch the x and y. So let's switch it. And then solve for y. So I'm going to subtract the 1 by both sides. Now I get x minus 1 is equal to 3y. Divide by 3 because we need the coefficient on y to be just 1. And now I have y inverse of this x minus 1 divided by 3. So the process here is about the same. If we have sine of y is equal to x and we want to find its inverse, then we're going to switch them, right? So now I get y equals sine inverse of x. The identities for inverses of cosecant, secant, and cotangent. And then we have our cotangent formulas. You will need them. These are images of what a sine function looks like and its inverse, the cosine function and its inverse, and the tangent function and its inverse. And then here's the whole gallery of them all that shows you the domains and ranges. So these are helpful visual aids as you work on this section. So now let's start on example 1. Example 1 says find the exact value in radians. So you want your calculator in radians degree mode and find the expression of sine inverse of 0. Well, if you plug it in your calculator, the sine inverse, make sure that you plug in, like mine, I have to do shift inverse. You plug it in, we get it's going to be equal to 0. We also know the interval that the sine inverse falls in is a negative pi halves to pi halves. All right, so this is the answer, 0. Now it says find the exact value in radians, the expression of arc sine of that negative square root of 3 halves. So that arc sine just means sine inverse. Okay, so now that we know that, we can type it in our calculator. And when we type it in our calculator, we're going to get a negative pi thirds. Okay. You can go up to the unit circle, find the negative, or find the square root of 3 halves for sine. We know it gives us a pi thirds, but it says that since we're moving in the negative direction, we'll go counterclockwise, or we'll go clockwise, excuse me. So whenever you're moving on the unit circle, if you go clockwise, that means our degrees or radians is negative. If you go counterclockwise, then that means it's positive. Example 3 says find that exact value. But it says now in degrees, so make sure your calculator's in degrees mode. We got cosine inverse of square root of 2 halves. Well, we know square root of 2 halves on the unit circle is pi fourths, which is 45 degrees, and that is our answer. We also know cosine falls on the interval of 0 degrees to 180 degrees, which makes sense because it's the x value on the unit circle. Okay, example 4. Find the exact value in radians of arc cosine. So that just says we're going to find the inverse of cosine. All right. Well, if you was to say what is the arc cosine inverse of the negative square root of 3 halves, you type it in your calculator, we're going to get a positive pi 6. So again, we're going to go find the exact value on the unit circle of the square root of 3 halves. And this negative is telling me it's going in a clockwise notation. It gives me pi half 6. Okay, so example 5 says, excuse me, my apologies. I'm just really hoping my computer will act up or not act up. Give me 1 second. Come on. There we go. My apologies, guys. I don't know why it keeps doing this. Here we go. Number 5. Let's talk about it. It says find the exact values in radians of the cotangent inverse. So whenever we talk about cotangent, we know that it gives me, hang on, let's just write it. Cotangent, before we talk about the inverse, is 1 over tangent, right? So we know it falls on the interval of 0 to pi. And the reason why is because our denominator, well, let's just look at it right quick. That means it's going to be 1 over sine cosine, which is written as cosine over sine. So tangent fell on the y-axis because the numerator was sine, but whenever we talk about the cotangent, we're talking about the flip, the inverse of it. It becomes cosine over sine. Does that make sense? Okay, so now let's find what it is. Well, we have to go up there to the top and use the formula that's given at the top. And it is pi halves minus my tangent inverse, right, of x. That's what it gave us at the top. Well, we have cotangent inverse of square root 3/3 is equal to pi halves minus tangent inverse of square root of 3/3. And when you type it in your calculator, we get pi thirds is our answer. Okay. Example 6 says find the cosecant, the arc sine of cosecant, which means it's the inverse of cosecant. So let's just rewrite it. I'm going to type it in my calculator, and it says round to 2 decimal places. The word approximated when you see the word approximate, it means it's not going to be exact form, where pi thirds is exact form, but if it asks you to do the approximation, we're going to find the decimal. That means we're going to be rounding to something. So after I typed it in my calculator, I get a negative 0.09. And that's rounding 2 decimal places as the direction called for. Okay. Now let's do the next example, 7. Get our screen to scroll down for us. All right, well, let's just work right here for right now. So we got we have tangent right, of this arc cosine. So whatever I find here, we're going to plug it in the tangent. That's what that's saying. So let's take what's in that parentheses and clean it up. It says arc sine, so that means we're taking the inverse of sine at that negative square root of 3/2. When you type that sine inverse of this negative square root of 3/2 in your calculator, it's going to give you a negative 60 degrees. All right, so now that we take that, we're going to take our tangent of that negative 60 degrees, and it's going to give me a negative square root 3. And that's our answer. And leave it in that root form because it said exact. So don't ever put it in decimal unless it asks us for you to. And let's see if we can get the screen to scroll down. There we go. Let's do number 8. Number 8 says find the exact value of the composition without using a calculator. Okay, so what we need to do is we see that we have the cosine inverse of cosine of this particular angle, right? So what I'm going to do is work on the parentheses first. You can go to the unit circle and find that 5 pi thirds, and you're going to notice the exact value there is 1/2. That negative sign told me that we're going clockwise to find that point. And now I'm going to take the cosine inverse of that 1/2 and plug it in, or go to the unit circle, and we know we get pi thirds, and that's our answer. Okay. Now let's get number 9. Let's get our screen to scroll down for us. Yay. Okay, so number 9, now we are solving for a circle with radius r. So let's, if you need to, write to the side of your paper what everything is. So we have a radius r, we have a central angle theta, and it intercepts a chord length of c. We are giving this particular function, and it says an airplane at 2184 feet, so 2,184 feet, flies directly over a gun that has a range of 2,275 feet, as shown in the figure below. What is the measure in degrees of the angle for which the airplane is within range of the gun? So the angle of which the airplane is in with range of the gun, this is where we'll put our answer. Here is our diagram, the picture drawn. So it's showing you that the gun is right here, right? And here is our airplane flying across above. So we need to know, because if you're flying an airplane and you wanted to be out of range of that gun, it'd be good to know what the range is, right? So since we are talking about a triangle, let's use the Pythagorean theorem. We know that it's a squared plus b squared equals c squared. However, in this here, we're going to replace a, b, and c, okay? We're going to let b be my chord, and in this case here, they called it c, right? We're going to let a be my height, and right here is our height, right? Because that's how far it's flying that above. And it's going to equal my r, my radius. Okay. Now, let's plug in what we know. Well, we know that height is 2184, and we're going to square it. We don't know the chord yet. We do know the radius, which is 2275, and we're going to square it. I'm going to subtract the 2184 squared from both sides. It's going to leave me with c equal to that. Now, if y'all want to crank out the numbers before we get to this part, you can. I'm going to go ahead and square root both sides. I know I get a plus or minus, but we are talking about a distance, and we're not going to have a negative distance. So we don't need the plus or minus. So that's going to give me C is equal to, let's clean this up a little bit more. Just so you can check your numbers, make sure that we agree on the same numbers. All right. So this is what we get. All right. So now we know what C is, but we are talking about half the distance. We're having to double it, right? Because of the squaring. So I'm going to say, okay, C is equal to that 637 plus the 637. And that gives me 1274. Now that I know all of that, I know what the chord is, I can plug it into my formula. So now I have 1 minus, and my C is 1274 squared. It's going to be divided by 2 times my R, which is 2275 squared. And then let's just crank it out. Round to the nearest tenths. Make sure you're in degrees mode. Okay, so I don't have, it's not going to let me scroll down on the screen. So I'm going to write the best I can right here. So it gives me cosine inverse of 0.8432, which is approximately, I'll come out here and write it where you can see it better, 32.5 degrees.